explain hybridization for organic. So hybridization is something that you've learned in Gen Chem, but you kind of revisit this in a different way in organic. So the three main hybridizations that you learn in organic is sp, sp2, and sp3, because organic is of course about carbon and hydrogen, and they can only do those two. Alright, sp and sp3 will still be the exact same way. When you have 4 bonds, when carbon's making 4 bonds, is sp, it's 4 sigma bonds, it will be sp3. And if I have 2 sigma, actually 3 sigma and 1 pi, it's going to be sp2. And then you have 1 sigma, actually 2 sigma, 2 sigma bonds and 2 pi bonds. It's going to be sp. Now sp2 will be a little different for atoms that contains a lone pair. So let's take amide as an example. Amide is this functional group where don't worry about what's on there, just worry about this middle group. Nitrogen has a lone pair in the amide group. Now this carbon's sp2, that oxygen's sp2. So the whole thing here is sp2. Now the lone pair in nitrogen atom, whenever there is a chance for that lone pair to donate to the sp2 system right next to it, it's going to do it. So this lone pair will donate to this sp2 system to make the whole structure more stable than what it is. So rather than this lone pair sitting in an sp3 orbital, it sits in p orbital, so it can move on the side on the neighboring sp2 system. So your rule for hybridization is whenever an atom that contains a lone pair is next to an sp2 system, directly right next to it, sp2 system, then that lone pair containing atom becomes sp2 as well. So that happens in amide. It also happens in ester. This can donate in. So this oxygen is also sp2 in ester. Same thing happens in carboxylic acid as well. Those are the functional group that you have to just know they're the exceptions to the hybridization rule. This will be helpful in doing a lot of problems, a lot of questions professors ask during your first exam. Right, I hope this helped.
The Teaching Center, UF's Learning Resource Center.